Okay, so we learned what to do now when in the cases when the sampling distribution of the population is known, and this we used it how when we want when we standardize our test statistic, right? We said that z is x bar minus mu over sigma over square root of n. What if sigma is not known? All right, so this is the title of this section. What if sigma is not known? As we learned before, and as we learned many times before, when sigma is not known, we estimate it. We estimate it by finding the standard deviation of the sample itself, S, right? But in this case, as we did in the confidence interval estimation, we cannot use Z anymore, but we're going to use the T statistic, okay, where it's almost the same, but instead of sigma, we have S here now, and we'll be looking into a T statistic, not Z statistic, and we will be looking into the table. But to look for the T table, we need also to pay attention to our degrees of freedom. Nu, remember, nu is n minus 1. Okay, and then you can find the right value of T, and we can use it to test our hypothesis. Now, the three types of tests are still applicable. It doesn't matter whether we are using a T or a Z for the test statistic. The description for the type of test is exactly the same. Now, what's changing here is only that we are using T, meaning that we are using S instead of sigma, and everything remains the same. All the conditions remain the same. Remember that how to find the p-value, and the rejection criterion is exactly the same as we did in the Z. All right, so all what we did here is we are changing the test statistic itself. And we're going to do next an application where we're going to use the T test statistic to conduct the test. All right, so let's apply the application or the testing hypothesis when we don't have when we don't know the standard deviation of the population. So here what we have is a manager for service station believes that car owners should rotate their tires, or she believes that people rotate their tires less frequently than recommended. All right. So this is her theory or her opinion, and later you'll see that we're going to represent that as being her alternative hypothesis. Okay. So she knows that in the manual they say that they have to rotate it 2 times per year, but she believed that this is not the actual practice. So what she did, she asked 14 car owners how many times they rotate their car's tires in a year, last 12 months. And these are the answers. So one person answered that I did it once, the other guy again the same, the other guy 2 times, the other guy nothing. He did not rotate them at all. And then we have 3, etc. So these are the answers. So these values represent the number of times that car owners have rotated their tires. The question is, does this data give us evidence about at the 10% significance level about the manager's opinion, whether she's correct or not? So what do we do here? First, we have to develop our hypothesis. We start always by the manager's question, right? So she believes that the car owners are not going by the manual, right? So which means she's saying that mu is less than 2 times. Okay, it's not. They are not doing it according to the manual. She says that it's less than that. All right. So which means now we can find what would be our null hypothesis, where everything will be the same except that the sign will be equal. So mu is equal to 2 times per year. What do we do next? We want to find the cutoff point to find the rejection region or the critical point. So the cutoff point for the rejection region. So you see that from the alternative hypothesis that this is a lower tail test, okay, or left tail test. So which means something like that. And I need to find this cutoff point, this one here, for a 10% significance level. So I know that this is 0.1, okay, 0.1. How can I find a t-value here? The table that we have, look at this. It shows us, let me first clean this up so that you can see it very clearly, because we're going to look for these values. Okay, get back the pen. So you can see here that the area is on the right hand side of the t's that we can read in the table. And so if I want to tell what's the t value that has an area on the left hand side, so I'm looking here and I know that this is 0.1. What can I do? I don't have it here, but I'm going to use the property of that curve that it's symmetrical with respect to the mean. So a t-value that has an area here of 0.1, okay, I read it in the table. So this value of t, it will be a minus t here, such that the area here will be 0.1. So that will solve my problem. So we look for the area of 0.1. Okay, and here we go. This is 0.1. And remember that we have a degrees of freedom of n minus 1, and we have n here to be 14. So we have to look for degrees of freedom of 13. So we look here, and this is our t. So t is equal to 1.35, but this 1.35 is this t. Since I need the area on the left hand side to be 0.1, so my t that I have, the one that I wanted here, okay, it's minus 1.35. Here we go. All right. Next, we're going to see whether we are inside the rejection region or we are outside. Okay, so this is the curve that we have drawn in the previous slide, and this is a clearer one. So we found t from the table. In fact, we deducted this t because in the table we read 1.35, but we know that it's symmetrical. So this one, it's minus 1.35, and this is our rejection region. So we will find now the test statistic. If we find the test statistic to be inside, we reject. Outside, we do not reject. As simple as that. Remember that the test statistic is now with t, right? Because we don't have sigma. So we're using the standard deviation of the sample. We can use a spreadsheet to find easily that sample standard deviation, or you can use the formula that we know by finding the variance and then square rooting it. So we look into X bar. By the way, it's very easy. Just sum up the values that these car owners have answered, divide by 14. This will be X bar. And as I told you, you can easily find it manually even, or otherwise use a spreadsheet. All right, so we find X bar to be 1.5 times per year, how many times they change the tire, and S is 1.16. Now I'm ready to find my test statistic. I plug everything in place, and we get minus 1.61. Minus 1.61, you can see that it's somewhere here, right? It's less than 1 minus 1.35. So inside the rejection region, as you can see it. By the way, it's something that I did not tell you before. Try to always, whenever you are doing a hypothesis test, draw the graph and see where is your rejection region. It will make it much easier for you to visualize your test. All right, so in this case, we reject HO, which means that we have collected enough evidence, sufficient evidence to support our alternative hypothesis, which is the manager's opinion. that car owners are doing or rotating their tires less than what's recommended by the manual. All right. So this concludes our topic. You can see that the technique of conducting the test is very, very simple. All what you have to do is to understand well the elements of the test and you'll be fine. If you have any questions, you know how to reach me. Thank you.